if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
When NASA turned its telescopes toward 3I/Atlas, they expected ice and dust. Instead, they found something that shouldn't exist. Welcome back to the channel, Space Explorers. Today, we're diving deep into one of the most mind-bending discoveries of 2025. And trust me, what NASA's James Webb Space Telescope just revealed about the mysterious object called 3I/Atlas is going to blow your mind. The mysterious arrival. It's 1st of July 2025, and astronomers at NASA's Atlas Survey Telescope in Chile are doing their regular scan of the night sky. Suddenly, their computers start beeping with alerts. They've spotted something that shouldn't exist, at least not according to everything we thought we knew about our cosmic visitors. Meet 3I/Atlas, officially designated C2025N1. The 3I stands for Third Interstellar.
So indeed, we are very lucky that we discovered this object because it is such a rare event, only third ever in our history to be detected.
Because this is only the third confirmed visitor from beyond our solar system that we've ever detected. The first was the famous cigar-shaped Oumuamua back in 2017.
A cigar-shaped object named Oumuamua was the first known interstellar object from outside our solar system in 2017,
which left scientists scratching their heads. The second was Comet 2I/Borisov in 2019. But 3I/Atlas? This one is rewriting the playbook entirely. Here's where things get absolutely fascinating. Most interstellar objects zip through our solar system so fast that we barely get a chance to study them before they vanish forever into the cosmic void. But 3I/Atlas is different. It's giving us an unprecedented opportunity to study an alien world up close, and what we're finding is both incredible and deeply unsettling. When astronomers first calculated its trajectory, they realized something extraordinary. This wasn't just any space rock that had wandered in from the cold depths between stars. 3I/Atlas was following a hyperbolic path, meaning it's definitely not from around here. It came from somewhere else entirely, another star system, another world, carrying secrets from places we can only dream of visiting. When NASA's $10 billion James Webb Space Telescope turned its incredible infrared eyes toward 3I/Atlas, scientists expected to see something familiar. After all, comets are basically dirty snowballs, right? Water ice mixed with rock and dust, maybe some simple organic compounds. That's Comet Science 101. But what Webb found made astronomers do a double take. Instead of the water-dominated atmosphere they expected, 3I/Atlas was surrounded by something completely different. The comet's coma, that glowing cloud of gas and dust that surrounds the nucleus, was absolutely dominated by carbon dioxide in an almost unbelievable amount. Here's the jaw-dropping part. The ratio of carbon dioxide to water in 3I/Atlas is about 8:1. That means for every molecule of water vapor, there are 8 molecules of carbon dioxide. To put this in perspective, this is one of the highest CO2 to water ratios ever observed in any comet, anywhere. Most comets from our solar system have ratios that are completely flipped. They're mostly water with just traces of other gases. Dr. Sarah Johnson from NASA's Goddard Space Flight Center described the discovery as like expecting to find a snowball and instead discovering a block of dry ice. The implications of this discovery are staggering, and they're forcing scientists to reconsider some fundamental assumptions about how comets form and what conditions existed in other star systems billions of years ago. But carbon dioxide wasn't the only surprise. Webb's near-infrared spectrograph also detected water ice, carbon monoxide, and something called carbonyl sulfide, a compound that's incredibly rare in comets from our own solar system. It's like 3I/Atlas is carrying a chemical fingerprint from an alien world, and that fingerprint is telling us a story we never expected to hear. the ancient time capsule. What makes 3I/Atlas even more mind-blowing is its age. Scientists believe this cosmic visitor could be older than our entire solar system. Think about that for a moment. While Earth was still a twinkle in a nebula's eye, 3I/Atlas was already formed, already wandering through the galaxy, carrying with it the chemical secrets of its birthplace. This is literally a time capsule from the dawn of the galaxy. The chemical composition that's got scientists so excited could represent conditions that existed in stellar nurseries billions of years before our sun even began to form. We're essentially looking at a fossil from the galaxy's youth, and it's telling us that the universe might be far more diverse and complex than we ever imagined. But here's where things get really spooky. The high carbon dioxide content suggests that 3I/Atlas formed in an environment that was dramatically different from the region where our solar system was born.
But then something weird happened. As it was moving away from the sun, it was slowing down, as you'd expect. But it wasn't slowing down fast enough.
Some scientists are speculating that it could have originated near a different type of star, maybe a carbon-rich giant, or even in the outer regions of a stellar system where conditions were far more exotic than anything in our cosmic neighborhood. What's keeping astronomers awake at night is the possibility that 3I/Atlas represents something we've never encountered before, evidence of planetary formation processes that are completely alien to us. If there are entire classes of comets out there with chemistry that is different from our own, what does that say about the potential for life in those systems? What kind of worlds could form from such exotic building blocks? The fact that we're seeing carbonyl sulfide, a compound that's extremely rare in our solar system, is particularly intriguing. On Earth, this chemical is associated with certain biological processes. Now, nobody's saying that 3I/Atlas contains life, but the presence of such unusual compounds is raising questions about what kinds of chemical processes might have been happening in its birthplace billions of years ago. The early activity puzzle. Scientists are baffled by 3I/Atlas because it began showing comet-like activity much farther from the sun than expected. NASA's TESS satellite revealed that the object was already outgassing at a distance of 6.4 astronomical units around Jupiter's orbit, when most comets usually wake up only inside Mars' orbit. This unusual behavior suggests that the comet's ices are either made of highly volatile materials or that some unknown process is driving the outgassing, defying current scientific understanding. The early activity of 3I/Atlas raises unsettling questions about its past. If it is so sensitive to radiation, was it slowly losing mass during its long interstellar journey as it encountered light from distant stars? Could it have shed a significant portion of its original material before even reaching us? Even more intriguing is the idea that this object may contain exotic ices that never form in our solar system, materials that can only exist in the ultra-cold depths of interstellar space. If true, we may be witnessing chemistry that Earth-based laboratories have never been able to reproduce. Adding to the mystery, the James Webb Space Telescope detected a strange, asymmetrical pattern in the comet's outgassing. Instead of producing a symmetrical coma, 3I/Atlas is venting gases preferentially toward the sun, giving it a lopsided shape. This unusual activity suggests that its internal structure might be fundamentally different from the comets we're familiar with, further highlighting how alien this visitor truly is. To make the situation even more dramatic, 3I/Atlas is currently on a hyperbolic trajectory through the solar system. It will swing around the sun in early 2026, releasing even more material under intense solar radiation before disappearing forever into interstellar space. Its closest pass to Earth will still be a safe 170 million miles away, but this fleeting visit is our only chance to study it. This object has traveled through the galaxy for millions, perhaps billions of years, passing unknown star systems and cosmic events, only to cross paths with us by pure chance. Whether coincidence or something deeper, its brief arrival is a rare reminder of the mysteries still lurking in the cosmos. The Formation Theory Revolution. The discovery of 3I/Atlas is rewriting long-held assumptions about how planetary systems form. For decades, astronomers believed our solar system offered a reliable model: rocky planets close to the star, gas giants farther out, and water-rich comets delivering the essential ingredients for life. But the strange chemical signature of 3I/Atlas, particularly its extreme richness in carbon dioxide, suggests it was born in a carbon-dominated disk, a type of stellar nursery very different from the one that shaped our solar system. This finding challenges the idea that our planetary formation template is universal. What unsettles scientists most is the possibility that comets like 3I/Atlas might be common in other star systems. Since comets play a crucial role in seeding young planets with water and organics, alien worlds receiving entirely different chemical payloads could develop in ways we've never imagined. This could mean atmospheres, oceans, and even life forms built on completely different foundations. Some researchers are even considering whether 3I/Atlas hints at alternative biochemistry pathways, where life could thrive using carbon dioxide and exotic compounds rather than the water-based chemistry we know on Earth. The comet's mysterious origins add another layer of intrigue. Unlike local comets, which can be traced to the Kuiper Belt or Oort cloud, 3I/Atlas has no clear return address. Its velocity and trajectory suggest it has been wandering through the galaxy for millions of years, making its exact birthplace nearly impossible to determine. It may have started its journey in a star system light years away, and over time, it has been shaped by cosmic radiation, passing stars, and gravitational tugs, yet it has preserved its alien chemistry across unimaginable distances. Even more haunting is the speculation that 3I/Atlas could be a refugee from a dead star system. If its parent star exploded as a supernova, the planetary neighborhood that birthed it may no longer exist. In that sense, this comet may be carrying the last chemical fingerprints of a destroyed world, an ancient messenger that has drifted alone through the void until finally crossing paths with our sun. Its survival and the secrets locked in its chemistry remind us that the universe holds far stranger possibilities than our earthbound imaginations often allow. The observational race. Right now, astronomers worldwide are in a race against time to study 3I/Atlas before it vanishes forever. Major observatories, from the James Webb and Hubble space telescopes to NASA's SphereX mission and ground-based networks, are pooling resources to capture every detail of this rare interstellar visitor. Each telescope offers unique strengths. Webb can analyze its chemical makeup, Hubble delivers sharp images of its structure, and SphereX monitors its activity as it nears the Sun. With no second chance to study this object, every observation carries immense weight for unlocking clues about planetary formation in distant star systems. What makes this effort remarkable is the unprecedented level of global collaboration. Research teams are sharing data in real time, treating the opportunity with the urgency usually reserved for rare cosmic events like supernovae. Even more exciting, results across multiple telescopes are consistent. Webb's discovery of carbon dioxide dominance has been confirmed independently, proving that this is no fluke, but something genuinely extraordinary in astronomical terms. The discovery has ignited debate about how 3I/Atlas compares to past interstellar visitors. Unlike Oumuamua, which had a mysterious cigar-like shape and unexplained acceleration, or 2I/Borisov, which resembled a normal water-rich comet, 3I/Atlas carries an unusual chemical fingerprint dominated by carbon dioxide. This diversity is puzzling scientists, raising questions about whether countless other exotic objects might have slipped past unnoticed, too faint or too strange for us to detect. Some astronomers believe these differences reveal just how varied planetary formation processes are across the galaxy, with each star system producing its own unique debris. Others suggest they could even represent different eras in galactic evolution, each object carrying chemical signatures of its time. The mystery has become so profound that experts are questioning whether our current classification system is enough. Should 3I/Atlas be treated as just another comet, or does it mark the beginning of a new category of interstellar objects entirely? The implications for alien life. While nobody's claiming that 3I/Atlas contains life, its unusual chemistry is forcing astrobiologists to expand their thinking about what kinds of environments might be capable of supporting living organisms. The abundance of carbon dioxide and complex organic sulfur compounds suggests that if life did exist in the stellar system where 3I/Atlas formed, it would have had access to a completely different toolkit of chemical building blocks than life on Earth. Instead of water-based biochemistry, alien organisms might have evolved to use carbon dioxide or other compounds as their primary solvents. This isn't just science fiction speculation. It's based on real chemistry. Laboratory experiments have shown that certain types of chemical reactions can occur in carbon dioxide-rich environments that would be impossible in water-based systems. If ancient microbial life existed on worlds in 3I/Atlas's home system, it might have operated on completely different principles than terrestrial biology. The presence of carbonyl sulfide is particularly intriguing from an astrobiological perspective. On Earth, this compound is produced by both geological processes and certain types of microorganisms. While the amounts detected in 3I/Atlas are consistent with non-biological formation, the fact that it exists at all in an interstellar comet opens up new possibilities for what biosignatures might look like in alien environments. Some researchers are even speculating that comets like 3I/Atlas could serve as vectors for spreading exotic biochemistry throughout the galaxy. If such comets regularly wander between star systems, they could potentially carry chemical compounds, or even preserved biological materials, from one stellar neighborhood to another. The carbon dioxide mystery. Let's talk about why the carbon dioxide discovery is so significant, because it's potentially revolutionary for our understanding of how planetary systems work. In our solar system, when comets form, they do so in regions where water ice is the dominant frozen material. This happens because water is incredibly abundant in the cosmos and freezes at relatively high temperatures compared to other compounds. So when you heat up a typical comet from our neighborhood, you get mostly water vapor with small amounts of other gases mixed in. But 3I/Atlas is flipping this script completely. The fact that it's spewing out 8 times more carbon dioxide than water suggests that it formed in an environment where CO2 ice was more abundant than water ice. This could only happen under very specific conditions, perhaps in a region around a carbon-rich star, or in the outer reaches of a stellar system where temperatures were so low that carbon dioxide could freeze out preferentially. What's terrifying scientists is the implication. If 3I/Atlas is representative of comets from its home system, then that system might have chemistry that's fundamentally different from ours. We're talking about alien worlds where the basic building blocks of planets and moons could be completely different from what we see in our cosmic neighborhood. But here's where things get really wild. Some researchers are speculating that the unusual chemistry of 3I/Atlas might be evidence of stellar environments that no longer exist in our galaxy. If this comet really is as ancient as scientists believe, it could be carrying chemical signatures from the early universe, when star formation processes were different and exotic types of stellar nurseries were more common. The technological triumph. The study of 3I/Atlas highlights a milestone in modern astronomy, showcasing how advanced our tools have become in exploring the cosmos. Using Webb's near-infrared spectrograph, scientists have been able to identify molecular fingerprints in the comet's coma from millions of miles away, something unimaginable just a few decades ago. What makes this even more remarkable is the speed and precision of the global scientific response, with teams publishing early results within weeks of the comet's discovery. Unlike the limited observations we had with Oumuamua in 2017, astronomers detected 3I/Atlas early enough to coordinate space-based and ground-based telescopes worldwide. This collaboration has produced the most complete picture yet of an interstellar object, tracking its motion, brightness, chemistry, and activity in real time. The effort demonstrates how the astronomical community has evolved to maximize rare opportunities, combining resources to capture data from every possible angle. Beyond the excitement of discovery, 3I/Atlas suggests that interstellar visitors may be far more common than once believed. In less than a decade, 3 such objects have been spotted, each offering a rare glimpse into material that formed around distant stars. By catching 3I/Atlas early, astronomers are learning about its chemistry and behavior, and also reshaping expectations about how frequently these cosmic wanderers pass through our solar system, and how many more may still be waiting to be found. The countdown to departure, 3I/Atlas, is currently racing toward its closest approach to the Sun, set for early 2026, glowing brighter and revealing more of its mysterious composition as it does. Yet, this brilliance comes with a sense of finality. Once it slingshots past the Sun, the comet will accelerate back into interstellar space, never to return. Scientists are racing against time, capturing every spectrum and image before this rare cosmic visitor disappears into the depths of the galaxy. But the bigger question lingers. What if 3I/Atlas isn't alone? Some researchers believe it could be part of a larger stream of interstellar debris, hinting that similar objects may soon follow. Identifying a family of such travelers could unlock secrets about alien planetary systems, offering humanity unprecedented glimpses into how worlds form beyond our own star. Each discovery adds urgency and excitement, as every interstellar comet is like a fragment of another solar system delivered directly to us. The implications stretch beyond science into philosophy. 3I/Atlas is a reminder that our solar system is just one small part of a larger galactic ecosystem, where gravity and time weave connections between stars. Studying these interstellar messengers allows us to sample alien chemistry without leaving Earth, and as technology advances, we may even trace them back to their origins. Whether 3I/Atlas is a lone wanderer or part of a cosmic fleet, its discovery marks the beginning of a new era in understanding our place in the universe. 3I/Atlas, a carbon dioxide-rich interstellar wanderer, is rewriting what we know about planetary formation and the diversity of worlds beyond our solar system. With its unusual chemistry and origins in a distant star system, it offers a rare glimpse into how alien planetary systems can differ from our own. And because scientists are racing to study this cosmic time capsule before it vanishes forever, its discovery marks one of the most thrilling moments in modern astronomy. What's your take on 3I/Atlas? Does its alien chemistry point to unseen formation processes, or something even stranger? Share your thoughts in the comments and subscribe for more space discoveries.